Are the Chinese crazy? That's the first question that comes to mind when you hear this story. In a vast desert covering 42,200 square kilometers, an area larger than some small countries, 12,000 farmers have managed to pull off something extraordinary. They turned barren sand into 4,000 acres of potato fields, producing 1.7 million kilograms of potatoes every year. Imagine the scale. It's like turning an entire desert into a giant green patchwork of food, with enough potatoes to feed tens of thousands of people. What makes this story even more remarkable is that it's not going unnoticed. Agricultural experts from Saudi Arabia, the United Arab Emirates, and other countries are visiting the site, eager to learn these techniques. But here's the real question. How did they do it? How did humans take one of the harshest, driest lands on the planet and turn it into a productive farm? And perhaps even more importantly, could this method work in deserts around the world? This isn't just a story about potatoes. It's about human ingenuity, resilience, and the power of science. It's about turning a natural challenge, desertification, into an opportunity for food security and ecological restoration. And as we follow this journey, you'll see how a small experimental plot in the Mu-Us Desert became a model that might inspire the world. Before we dive into the miracle of potatoes in the desert, it's important to understand why this project matters so much. China isn't just turning sand into food for fun. This is a response to one of the world's most serious desertification challenges. At one point, 2.622 million square kilometers of Chinese land were affected by desertification, roughly 27.4% of the entire country. That's an area larger than entire countries like Chile or Zambia. These deserts aren't just empty land. They generate frequent sandstorms that blow over cities and farmlands, destroying crops, threatening lives, and creating economic losses. People and livestock have been swept away in these storms, while villages nearby often live under constant threat. For decades, China has been fighting back. Since 1988, the country has planted more than 100 billion trees in desert areas and restored 280 million acres of land. They've also set up 41 demonstration zones to showcase desert control and ecological restoration techniques. These efforts have successfully slowed desert expansion and created a pattern known as green advancement and desert retreat. Yet, even with these achievements, one challenge remained: turning deserts into farmland. Trees and shrubs can stabilize sand, but growing crops in such harsh conditions seemed almost impossible. That's what makes the Mu-Us Desert Potato Project so revolutionary. It moves beyond ecological restoration to productive, sustainable agriculture in a place where nothing seemed to grow. This is the stage where science, innovation, and human perseverance come together to challenge what was once considered impossible. Now that we understand why desertification is such a massive problem in China, let's zoom in on one of the most dramatic transformations, the Mu-Us Desert. Located in northwest China, the Mu-Us Desert was historically one of the country's largest sources of sand and dust. Every year, strong winds would sweep sand into nearby cities and farmlands, causing sandstorms that disrupted daily life, ruined crops, and made living conditions extremely harsh. This desert was also one of the poorest regions in China, with communities struggling to survive in an unforgiving landscape. But things began to change when Chinese scientists and local farmers joined forces to manage and transform this desert systematically. Instead of just planting trees here and there, they developed a comprehensive desert management plan, combining ecological restoration with agricultural experimentation. The results are staggering. Today, the Mu-Us Desert is no longer just a vast expanse of sand. It has become a place of green hope. Around 4,000 acres of potatoes have been planted, and the once barren landscape is slowly transforming into productive farmland. This transformation isn't magic. It's the result of careful planning, scientific research, and human perseverance. The Mu-Us Desert now stands as a testament to what's possible when communities work with science to overcome extreme environmental challenges. This sets the stage for the next step: how exactly they made potatoes grow in such a harsh environment, which involves innovation, experimentation, and smart use of natural resources. Turning a desert into a potato farm might sound impossible, but in the Mu-Us Desert, science and ingenuity made it happen. The conditions here are extreme. Annual rainfall is only 250 to 440 millimeters, which is barely enough to sustain most plants. The soil is sandy, nutrient-poor, and constantly shifting with the wind, far from ideal for agriculture. Chinese scientists started small, experimenting with drought-tolerant saplings and a method called minimally invasive planting. This technique carefully places plants without disturbing the fragile desert soil, which helps them survive in the harsh environment. Once the trees started thriving, the team realized that crops might also grow with the right strategy. Water was the biggest challenge. To solve this, they turned to flood irrigation, an ancient method that channels seasonal river floods into the desert. This not only watered the soil but also deposited nutrient-rich silt, slowly improving its fertility. Imagine the desert drinking up life-giving floods and becoming a fertile bed, almost like turning a dry sponge into a green oasis. The first 20-acre experiment was a test of patience and skill. Local farmers and scientists planted potatoes underground, carefully monitoring moisture, soil quality, and temperature. The result? 3,000 kilograms of potatoes, averaging 150 kilograms per acre. While this was much lower than typical farmland, it proved that desert cultivation was possible. Encouraged by this success, the government invested $350 million to scale up the project. Scientists conducted extensive soil and climate research, identifying areas with the highest potential for crop growth. By combining technology, ancient techniques, and modern research, they created a blueprint for sustainable desert farming, a strategy that could be replicated elsewhere. This meticulous approach shows that the success in Mu-Us was not luck. It was the result of careful science, experimentation, and planning. Once the initial 20-acre experiment proved that potatoes could grow in the desert, the next step was expansion. The project didn't just stay in the hands of scientists, it involved the local community. Nearly 12,000 farmers from surrounding villages joined the effort, transforming a small experiment into a large-scale agricultural movement. Scaling up wasn't easy. Managing thousands of acres in shifting sand required careful planning, irrigation coordination, and ongoing monitoring. But over several years, the project expanded to 4,000 acres, all planted with potatoes. By 2023, the desert was producing 1.7 million kilograms of potatoes annually, with a yield per acre reaching 430 kilograms. That's a staggering increase compared to the first trial, showing that persistence and innovation really do pay off. The benefits weren't just agricultural. Farmers saw their annual incomes rise, with some earning over $10,000 a year, a huge improvement in a region that was once extremely poor. Economically, the project injected vitality into the local community, creating jobs, stabilizing incomes, and encouraging younger generations to stay in the region instead of migrating for work. Environmentally, the project also stabilized the desert. Potato plants, combined with afforestation and soil management, reduced sand movement and helped improve soil fertility. What was once a barren landscape gradually became a green patch of hope, demonstrating how human intervention can turn extreme conditions into productive land. This phase proves a key lesson. Small experiments can grow into transformative projects, but success requires collaboration, scientific guidance, and local participation. The Mu-Us Desert was no longer just a test site. It became a model for sustainable desert agriculture. By the time the project had scaled to thousands of acres, the Mu-Us Desert was undergoing a remarkable transformation. not just in terms of crops, but in its very ecology. Through flood irrigation, afforestation, and careful soil management, nearly 94% of the desert area was effectively controlled, turning shifting sand into stable, fertile land. This wasn't just a win for potatoes. It was a victory for the environment, slowing desertification and helping protect surrounding areas from sandstorms that once wreaked havoc on towns and farms. The social impact was equally impressive. More than 30 villages in the region experienced a real improvement in living conditions. With food production stabilized, families could rely on a consistent source of income and nutrition. Communities once plagued by harsh desert conditions found themselves thriving in ways that were unimaginable a decade ago. Economically, the potato project became a preferred crop, generating new revenue streams for farmers. For some, annual incomes exceeded $10,000, providing a dramatic boost in regions that were historically impoverished. This created a cycle of growth. As farmers earned more, they could invest in better tools, seeds, and irrigation, further improving productivity. On a global scale, the project offers a powerful lesson. Deserts, often seen as barren wastelands, can be transformed with the right combination of science, innovation, and local engagement. It links agriculture with climate adaptation, showing that human ingenuity can simultaneously address food security, ecological restoration, and sustainable development. The Mu-Us Desert Project proves that economic, social, and ecological benefits can go hand in hand, creating a blueprint for other arid regions worldwide. It's a vivid example of how turning challenges into opportunities can produce multidimensional gains that ripple far beyond the original site. The success of the Mu-Us Desert Project didn't stay a local story. It caught the world's attention. In 2023, agricultural experts from Saudi Arabia, the United Arab Emirates, and other countries visited the desert to study how China had managed to turn sand into a potato farm. For nations struggling with arid lands, these methods were more than inspiring. They were potentially game-changing. China's approach combines science, technology, and community effort. By carefully managing water through flood irrigation, planting drought-resistant crops, and restoring vegetation with afforestation techniques, China created a replicable model that other desert regions could adopt. For instance, the knowledge gained here could help parts of Africa, the Middle East, and Central Asia, where food security is threatened by harsh climates. The global interest also highlights an important lesson. Innovation in one corner of the world can have international ripple effects. Countries facing desertification don't need to start from scratch. They can learn, adapt, and improve upon proven methods. China's example proves that even extreme environments can be transformed with the right combination of research, investment, and community participation. This attention also reinforces the idea that food security and climate adaptation are interconnected. If the techniques used in Mu-Us can be scaled globally, deserts could become productive landscapes, reducing hunger, supporting local economies, and helping stabilize fragile ecosystems. In short, the Mu-Us project has turned China into a leader in desert agriculture, showing the world that human ingenuity, when combined with technology and determination, can rewrite what's possible in barren lands. From a vast, barren desert to a thriving potato-producing landscape, the Mu-Us Desert story is a testament to human ingenuity, science, and persistence. What began as a small 20-acre experiment has now grown into 4,000 acres, producing 1.7 million kilograms of potatoes annually and involving 12,000 local farmers. This transformation not only stabilized the desert but also improved the lives of people in more than 30 surrounding villages. Beyond just farming, this project demonstrates the power of strategic innovation in extreme environments. By combining traditional knowledge with modern science, like flood irrigation, drought-tolerant crops, and ecological restoration, China has created a replicable model for turning deserts into productive land. The implications are massive: improved food security, higher farmer incomes, and ecological restoration that can combat desertification and even influence climate adaptation strategies globally. The story also raises a broader question. Could human ingenuity turn other deserts into fertile lands? If similar methods are applied in Africa, the Middle East, or Central Asia, we might see deserts worldwide becoming engines of food production and ecological resilience. This is not just about potatoes. It's a symbol of what careful planning, science, and community effort can achieve. It's about turning challenges into opportunities and showing that even the harshest environments can support life, livelihoods, and sustainability. If you're inspired by this story of innovation and want to follow more global projects that push the limits of possibility, make sure to subscribe to the channel and turn on notifications. There are countless lessons from around the world waiting to transform the way we think about agriculture, environment, and human potential.